5.7 Proving that figures are special quadrilaterals. On page 255 and page 256, there are lists on those pages helping you to prove rectangles, kites, rhombuses, squares, and isosceles trapezoids. Please take a look at those pages in the next few days and as we go along with these lessons and in your homework, and memorize those, because those are the tools that you're going to be using in order to solve these problems. In our first example, we see that we are given 4 vertices of a quadrilateral, and we need to define it with its most descriptive name. What I'm going to do is I'm going to plot the points and connect them to kind of get a general idea of what the figure will look like. If we take a look at the list in the book, a few of the things that we can use in order to classify quadrilaterals are the lengths of the sides and the angles, to see if they're congruent, if they're perpendicular, if they're parallel, etc. In this case, the slope of the line will also help us in doing that. Slopes of the lines will help us prove if it is a parallelogram and or just a regular quadrilateral. So what I'm going to do is I'm going to find the distance first. And I labeled each of these points A, B, C, and D. So I am going to find the distance between A and B. And if you remember the distance formula, it's the square root of x2 minus x1 squared plus the quantity y2 minus y1 squared. And this is all under the square root. So for A to B, I'll get 8 minus 3 squared plus the quantity 1 minus 2 squared. This will give me 25 plus 1, which will be square root of 26. Go ahead and calculate the distance now between B to C, then C to D, and finally then A to D. So pause this video and calculate those distances. What you find out is that they all are the square root of 26. Now, what this first does is this proves that the figure is a parallelogram because it has 2 pairs of opposite sides congruent. What you'll then want to see, or then what you'll see, is that since all 4 of the sides are congruent, that implies a rhombus. If you look on page 256 under proving a quadrilateral is a rhombus, based on number 1, if a parallelogram contains a pair of consecutive sides that are congruent, then it is a rhombus. And again, these are consecutive sides, so this does prove it's a rhombus. Now, what we do need to figure out, though, is if it is indeed a square or just a rhombus. So to do this, what you will do is you will calculate the slopes to see if they're perpendicular. Because if we look at the qualifications for a square, we need to prove that a quadrilateral is both a rectangle and a rhombus. And to be a rectangle, if we look at 255, number 1, it states that a parallelogram contains at least one right angle. And we can define a right angle with perpendicular lines. So what we'll do is we'll calculate the slope of AD, and then we'll calculate the slope of AB. So this in here, we'll figure out if those angles are perpendicular. To calculate slope, we'll use y2 over y1 over x2 minus x1. And so for AD, That'll be 7 minus 2 over 2 minus 3. That's going to give us 5 over negative 1. For AB, it'll be 1 minus 2 over 8 minus 3, which will give us negative 1 over 5. Now, although these are both reciprocals, they are not perpendicular, therefore it cannot be a rectangle, therefore it cannot be a square. Therefore, the most descriptive name for this one would be a rhombus. Example number 2, we're given that ID bisects RB and that line segment BI is congruent to line segment IR. And what we're trying to prove is that bird, BIRD, is indeed a kite. If we look at page 256 of proving that quadrilateral is a kite, there are 2 ways we can do this. The first one is if 2 disjoint pairs of consecutive sides of a quadrilateral are congruent, then it is a kite. And 2, if one of the diagonals of a quadrilateral is the perpendicular bisector of the other diagonal, then it proves it to be a kite. Well, if we look at what's given, we're halfway there in proving that it is a kite based on the second statement, that if we have a perpendicular bisector. From the given, what we can say is that BX is congruent to RX, and we already know that BI is congruent to IR. Now, if we remember the equidistance theorem, since I have 2 sets of congruent segments, that implies that ID is a perpendicular bisector. So we'll put that into our 2-column proof, again that BX is congruent to RX based on the definition of bisecting. And then we can go to say that ID is a perpendicular bisector of BR based on the equidistance theorem. If 2 points are equidistant from the endpoints of a segment, then they create a perpendicular bisector. Well, since ID and BR are both diagonals, and we just stated that they are perpendicular bisectors, then that does prove that bird is indeed a kite. Let's take a look at our last example. In this figure, we're given a quadrilateral, and we're shown the following markings. The inside angle of the diagonals, this right here, is indeed a right angle. We can first tell that this figure is a quadrilateral because if we remember back to 5.6 in proving quadrilateral, and if we look at number 4 on page 249, it says if the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. So we can at first establish that, yes, this is a parallelogram. From there, we need to figure out more specifically what kind of parallelogram this is. And again, most of this diagram has to do with the diagonals. And so more specifically, we can look at, there's a right angle. So what figure forms a right angle with its diagonals? So again, if we look at our list, we can again go to a rhombus, and the reasoning for number 3. If the diagonals of a quadrilateral are perpendicular bisectors of each other, then the quadrilateral is a rhombus. Well, we already know they bisect each other. That makes it a parallelogram. But now it's a perpendicular based on the right angle. Therefore, the most descriptive name for this one would be a rhombus.